Welcome to The Explainer. Today, we are literally unlocking the secret language of algebra and discovering what I like to call its ultimate cheat codes. If you've ever looked at a page full of letters and numbers and wondered how they all fit together, or, how you could use them to do massive calculations in your head in seconds, well, you're definitely in the right place. Okay, let's dive into this.
Here's a quick look at our roadmap for today. We'll start by meeting the father of algebra, then decode the polynomial puzzle, classify them into monomials, binomials, and trinomials, unlock those ultimate algebraic cheat codes, and finally, wrap up with some real number math magic.
Section 1. Meet the father of algebra.
So, meet Mohammed bin Musa al-Khwarizmi. He was an absolutely incredible Islamic mathematician who lived from 780 to 850 AD. And he was a true pioneer. He wrote extensively on Hindu-Arabic numerals, and his groundbreaking treatise, titled Hisab Algebra wa Muqabala, is actually where we get the modern English word algebra. He's widely considered to be the founding father of this entire field.
Now, what's really interesting here is the original literal translation of that Arabic word al-jabar. It means reduction or completion, and I really want you to keep that in mind as our guiding light today. You see, algebra isn't about making things more complicated by adding letters. Actually, it's fundamentally about reducing complex, messy realities into simple, elegant, and solvable structures. It is the ultimate tool for simplification.
Section 2. Decoding the polynomial puzzle. Okay, think of a polynomial as a standard, well-behaved algebraic sentence. By definition, a polynomial is an algebraic expression where the exponent of the variable, that little number hovering above your x or y, is a whole number. This is the absolute golden rule. If the exponent is a fraction or a negative number, it gets kicked right out of the polynomial club. It has to be a nice, clean, whole number, like 1, 2, 3, and so on.
Let's look at a quick side-by-side to clear this up. On the left, we have a perfectly valid polynomial, 3x squared plus 2x plus 4. The exponents on the variables are a 2 and an invisible 1. Both of those are whole numbers, so we're good. But look at the right side. We have the square root of x. In math, a square root is actually a fractional exponent. It's x to the power of 1/2. Since 1/2 is not a whole number, that expression is an invalid polynomial. It literally breaks our golden rule.
Now, just like spoken words have emphasis, polynomials have what we call a degree. And this is a super simple concept. You just scan the polynomial and look for the biggest exponent. Whatever the highest power is, that's the degree of the whole expression. So, in our example right here, 8x cubed plus 4x squared plus 6x plus 9, the highest power you can spot is the 3. Therefore, it's a third-degree polynomial. It's really just a quick way of sizing up how powerful the expression is.
Section 3. Monomials, binomials, and trinomials.
If you know your basic prefixes, you already know how to name these polynomials. A mononomial uses the prefix mono, meaning one, kind of like a monocle with one lens. It's an expression with just a single term, like 3x squared. A binomial uses the prefix bi, meaning two, like a bicycle with two wheels. It has two terms, for example, 2y squared plus 7. And finally, a trinomial, just like a tricycle, has exactly three terms, 7x squared plus 2x plus 6. Honestly, once you spot these patterns, reading algebra feels as natural as reading English.
Section 4. Algebra's ultimate cheat codes.
So, if I asked you to multiply something massive and complex, your very first instinct might be to write it all out and do the tedious line-by-line multiplication. But what if I told you there's a shortcut? Is there a way to bypass all that grueling work?
The answer is a resounding yes. And they're called basic algebraic identities. Think of these as the universal laws of math. An identity is simply an equation that is always true, no matter what crazy numbers you decide to plug into the variables. They're formulas that mathematicians discovered, tested, and proved just so that you and I don't have to reinvent the wheel every single time we do multiplication.
And this brilliantly illustrates our first two foundational cheat codes. On the left, the square of a sum. If you have two numbers added together n squared, like a plus b all squared, it will always equal a squared plus 2ab plus b squared every single time. On the right, we have the square of a difference. Notice how incredibly similar it is. A minus b all squared equals a squared minus 2ab plus b squared. The only thing that changes between these two massive formulas is that single plus or minus sign in the middle. Once you memorize this pattern, you're going to expand complex expressions instantly.
But wait,
There is a third core identity, and honestly, it might be the most powerful one of the whole shebang. It's called the difference of squares. If you see a perfectly squared number minus another perfectly squared number, a squared minus b squared, you can instantly break it apart or factorize it into a minus b multiplied by a plus b. It's an incredibly elegant shortcut that makes nasty-looking subtraction problems completely vanish into clean, simple multiplication.
Section 5. Real number math magic.
Let's put this into practice. Let's say you need to find the square of 103. 103 times 103 on paper? That takes a minute, but let's use our cheat code. Step 1. Unmask the number. 103 is really just 100 plus 3. Step 2. Apply our square of a sum identity. We treat 100 as a and 3 as b. Step 3. Solve it out. 100 squared is a nice, easy 10,000. 2 times 100 times 3 is 600, and 3 squared is 9. Add them up in your head. 10,000 plus 600 plus 9 is 10,609. Boom! You just squared a 3-digit number using algebra without even breaking a sweat.
So the absolutely crucial point here is that this works in reverse too. What if we need to square 87? 87's messy, but it's very close to a nice round number. Step 1. We rewrite 87 as 90 minus 3. Step 2. Now we use our square of a difference identity. Step 3. Let's solve it. 90 squared is 8,100. Then we subtract 2 times 90 times 3, which is 540. Finally, we add 3 squared, which is 9. So 8,100 minus 540 is 7,560, plus 9 gives us exactly 7,569. Again, we just took an awful calculation and turned it into manageable mental stepping stones. Okay, let's look at one more, using our final identity. Imagine trying to multiply 107 by 93. Without a calculator, that sounds horrible, but look closely at the numbers. 107 is exactly 7 above 100, and 93 is exactly 7 below 100. Guys, this is just the difference of squares identity in disguise. We rewrite it as 100 plus 7 times 100 minus 7. The identity tells us this will simply equal 100 squared minus 7 squared. That's 10,000 minus 49, giving us a final answer of 9,951. Honestly, it takes longer to explain it than to actually do it in your head.
And that brings us to the end of our journey today. We've seen how algebra reduces the complex into the simple, and how polynomials and identities are just powerful tools waiting right there in your mental toolkit. So I want to leave you with one final challenge, to test out your new skills. Armed with the difference of squares identity we just learned, how quickly can you solve 99 squared minus 1? Think about how you can break that apart using the rule. I bet you can do it in your head in under 5 seconds. Thank you so much for joining me on The Explainer. Keep practicing those mathematical cheat codes, and I'll catch you next time.